Good morning, students. This is Nagesh Patil, Department of Chemistry, Vershav College, Ballari. We are discussing on material science. This is for BSc 6th semester student in organic 6.2. So, what is material science? Material science is a branch of applied science concerned with investigation the relationship existing between the structure of material and their characters, property, and use of the various materials such as metals, ceramic, and plastic that are employed in science and technology. So we all know that. So it include all the part, that is engineering design, chemistry, physics, crystallography, bioenvironmental science, chemical engineering, architecture, product design, and then mechanical, civil engineering. So it will concern to almost all the departments. So in material science and then engineering. So then the study of characteristics and use of the various materials such as metals, ceramics, and plastic that are employed in science and then technology. We have to improve it. So that's why we need this science and technology. So the traditional example of materials what we are using in the olden days, that are metals and semiconductors, ceramics, and as well also polymers also. But nowadays new and advanced material that are being developed included non-materials as well as the bioplastic also. So by arrangement of the atoms in a matter, so the materials are generally divided into two classes. So one is crystalline, another one is non-crystalline. So the crystalline solids are the material whose constituents such as atoms, molecules, or ion are arranged in a highly ordered microscopic structure. So it has a definite shape, so forming crystal lattice that extend in all direction. Then what about this amorphous? So the name itself indicating amorphous, that is aiming without shape. So that is a non-crystalline solid, is a solid that lacks a long range order characteristic of the crystal. So it doesn't have a type of a regular shape for it. So that's why we'll call it as a amorphous or non-crystalline material. A glass is the best example of amorphous solid that exhibit a glass transition. Then polymer are often amorphous, and other type of amorphous solid include gel, thin films, nanostructure material, and then other materials also we can look at it. So here it have given one figure that shows a highly arrangement of an atoms in a microscopic structure, so that makes a matter in a definite shape, that is a crystalline, so it is having a definite shape. But here in non-crystalline, so the atoms in a matter, they are not arranged in a proper way, so they are arranged in a randomly, so that's why it doesn't show any type of shapes here. So these are all coming under non-crystalline and nothing but a amorphous in nature. So then why we need this, why, how that material science is important? So that material, what is material? Material is defined as a substance that is intended to be used for certain applications. So what are those applications? That are many a material around us that can be found in anything from building a building to a spacecraft. So we need to improve the material. So like structure, so we have to improve the structure of that material, we need to improve it. Then property, we have to improve the property. Then you have to improve the performance, we have to improve the processing, then we have to improve the characterization. So that's why we need these material sciences. So then this deals with the atoms of that material, so we have to go out for the atomic level, so then only we can improve all the performances and how they are arranged to give molecule crystals. Much of the electric and then magnetic and chemical properties of the material arises from this level of structure. If you want to know the magnetic property of the component, then you should know the up to atomic level, so then only we can perform it. The length scale involved are in angstroms, the way in which the atoms molecules are bonded and arranged in a fundamental to study the property of behavior of any material. To improve it, we have to go at atomic structure. Then the classifications of metal alloys. So the majorly metal alloys has been classified into two types. So one is ferrous, another one is non-ferrous. So ferrous means the name itself indicating it should consist of iron. So the iron, it is the major constituent in it, and the other constituent, it may be a carbon, that is greater than 1.4 percentage. So that is, we can call it as a steel. Then cast iron, it may be 3 to 4.5 percentage of an carbon. So that is called as cast iron, and the remaining major constant is iron. So that is coming under ferrous. Then non-ferrous, other than iron, so other materials may be in a larger quantity. That may be a copper, aluminum, magnesium, and then some of them titanium also. So then ferrous alloys in a primary constituent, that in alloy, are so brittle that performing by a deforming is not possible ordinary or cast iron. So we need a ferrous alloys because it is a non-corrosive in nature. So we have to improve it. So how we are going to improve? By adding some other materials. So what is ferrous alloys? So that is cast iron are called so because they are usually manufactured through casting technique, owing their brittle nature due to presence of iron carbide. So these are the properties of ferrous alloys. So steels are serving major part of the present engineering applications here. So steel making a very important thing. Then however cast iron so mostly serve as structural components. So example in automobile casting, and then lathe bed, then sliding guides in machineries. So most of them we are using a cast iron. So then other somewhat the drawbacks here it is for ferrous alloys. So the drawback is a poor corrosive resistance. So it is very eager towards the atmospheric oxygen, then it will become more corrosive. Then the mechanical property and chemical property will get destroyed if it is very reactive towards the atmospheric oxygen. Then one of the major drawback is higher density and then low specific strength. So as the material will interact with the atmospheric oxygen, so the density will become higher, then it has having a low specific strength due to corrosiveness in nature. Then low thermal and electric conductivity also it is a major drawback for the ferrous material. So then classification of this, it is entirely based upon the percentage of carbon present in the ferrous alloys. So that is carbon is below than 2.14 we can call it as a steels, and then above 2.14 we can call it as a cast iron. It is entirely depend upon the percentage of carbon here. So then what is non-ferrous material? So metal element and alloys are not based on iron. So iron is not the major constant here. So such type of materials we can call it as a non-ferrous metals. So most important one is aluminum, copper, manganese, nickel, titanium, zinc and their alloys. So alloys are nothing but a homogeneous constitution of a metal with non-metal, metal with metal. They should be clear that it should be a homogeneous. So although not as strong as steel, certain non-ferrous alloys have strength to weight ratio that makes a competitive with steel in some application. When compared to these non-ferrous alloys, ferrous alloys have a greater application. So one of them is steel. So many non-ferrous metals have property other than mechanical that make them ideal for application in which steel could not be suitable. Then what are the terminologies we are using in this material sciences? One is a phase. A phase is defined as any homogeneous and physically distinct part of a system having all physical and chemical properties the same throughout the system. A system may consist of one phase or more than one phase. It is called as a phase. Simply we can call a system containing only liquid water is one phase system. We cannot distinguish into a two layers, so that we can call it as a phase. A system containing liquid water and then water vapor, so we can distinguish water vapor as well as a liquid vapor. So then we can call it as a two-phase system. Two-phase system. A system containing liquid water, water vapor and solid ice, then we can make it into three different parts. So that is a three-phase system. So pure substance, solid, liquid or gas made up of one chemical species only is considered as only one phase. Thus oxygen, benzene and ice are all one phase. Either it will be a solid, either it will be a liquid, either it will be in a gaseous state. Then the transformation taking place, how solid, liquid, then gases. So most phases transformation do not occur instantly. They begin by the formation of numerous small particles of the new phases, which increases in size until the transformation has reached completely. The two stages of phase transformation taken place. So one is nucleation, another one is growth. What is nucleation? So the nucleation involves the appearance of very small particles or nuclei of the new phase which are capable of growing. Then growth are nothing but during the growth stage these nuclei increases the size which result in the disappearance of some all the parent phases. So it will growth, so it will move from one part to another part. So we are, so the nucleation once again it is of two types. Then homogeneous nucleation, another is heterogeneous nucleation. Homogeneous nucleation, nuclei of the new phases are formed uniformly throughout the parent or original phases. But in heterogeneous nucleation, nuclei of the new phase forms preferentially at heterogeneities. So the energetic of this process are typically different. They are completely different in nature.